Hello, and welcome to today's podcast. We're diving into a topic that's really close to my heart: model evaluation in machine learning. If you're anything like me, when you first stepped into the world of machine learning, it probably felt like trying to drink from a fire hose. The sheer volume of techniques and methods can be overwhelming. I remember those early days, feeling like I was drowning in information. That's why I decided to put together this guide. It's the resource I wish I'd had back then. A conversation, a journey, and a bit of mentorship all rolled into one. Now, why is this guide different? Well, think of it as having a chat with a friend who's genuinely excited about the topic. So, let's dive in together, shall we? Before we get into the nitty-gritty, let's start with why model evaluation matters so much. It's not just about seeing if our model is good. It's about understanding if it performs well in the real world. Traditional metrics like pass and fail don't directly apply to machine learning models. Instead, we're talking about achieving genuine business value. It's a blend of metrics and techniques that go way beyond just accuracy. Speaking of accuracy, let's talk about why it's not always the best metric. When you're just starting out, accuracy was like the obvious choice, right? But as I learned with one of my clients, relying solely on accuracy can lead to failure in production. That's when precision and recall come into play. Precision measures the quality of our positive predictions, while recall tells us how many actual positives our model captures. Imagine you're building a model to detect rare diseases. You'd want to focus on recall to avoid missing potential cases because false negatives could have dire consequences. On the flip side, for something like a spam filter, where false positives are costly, precision becomes crucial. Once you've got precision and recall down, you'll hear about the F1 score. It's this beautiful balance between the two, considering both false positives and false negatives. But it's surprisingly nuanced and isn't always the best choice for every situation. Then there's the AUC-ROC curve, a powerhouse for binary classification problems. It looks at the trade-offs between true positive rates and false positive rates across different thresholds, giving us a comprehensive view of our model's performance. Now, let's talk about cross-validation. When I first learned about this technique, it felt like a game changer. Cross-validation ensures our model generalizes well to unseen data. The classic method is k-fold cross-validation, where the dataset is split into k parts. Each part is used as a test set, while the others are used for training. This repeats k times, and we average the results. It's robust and helps tackle overfitting, a common pitfall where a model performs perfectly in development, but fails in the real world. Another sneaky issue in model evaluation is data leakage. I've seen many models with stellar performance in the lab that bomb in production due to data leakage. It happens when information from outside the training dataset is inappropriately used to create the model. To avoid this, make sure your test data is completely separate from your training data. Now, let's touch on hyperparameter tuning. It's this beautiful blend of art and science, finding the optimal set of hyperparameters to boost your model's performance. Techniques like grid search and random search are staples, but Bayesian optimization often provides better results with fewer trials. It's a clever technique that helps models generalize better by reducing overfitting. Handling imbalanced data is another challenge in model evaluation. Picture trying to predict fraud in credit card transactions where fraud is rare. Your model might predict no fraud every time and achieve high accuracy, but that's not useful for actual fraud detection. Techniques like resampling or using ensemble methods can really help. Finally, let's talk about bias and fairness. In today's world, ensuring your models are not just effective, but ethical is crucial. I remember a project where we unintentionally built a biased model. It taught me the importance of evaluating fairness early on. Fairness metrics can be tricky to implement, but they ensure your models are deployed responsibly. As we move into 2025, developing AI systems ethically is vital for mitigating risks and maximizing benefits. And there you have it, a whirlwind tour of mastering model evaluation in machine learning. I hope this conversation helps demystify some of the complexities and empowers you to build models that aren't just good, but genuinely valuable and ethical in the real world. Thanks for joining me today, and until next time, keep learning and exploring.